Myself K.Raghavendra Rao, working as assistant professor in ECE department in PSCMRCET Vijayawada. Today we are going to discuss about transistor and high frequency. To analyze the transistor at high frequency, assume either PNP or NPN transistor. If you see the construction of either PNP or NPN transistor, we have three terminals. Those are emitter, base, collector. As we know already, in the transistor, between emitter and base junction, we have diffusion capacitance. Similarly, between collector and base junction, we have transition capacitance. I repeat, between emitter and base junction, we have diffusion capacitance. Between collector and base junction, we have transition capacitance. The reactance of the capacitance at low frequency is more. Reactance of the capacitance is more at low frequency. So that diffusion capacitance and transition capacitance act as open circuit at low frequency. So earlier already we have discussed this parameter model. In the parameter model, these diffusion and transition capacitances not existed in the parameter model. Already we have discussed in earlier classes. So coming to the transistor high frequency. At high frequency, both diffusion capacitance and transition capacitances cannot be ignored. Why? Because at high frequency, the capacitance offered by the frequency offered by the capacitance is very high. So the reactance will be very less. So that at high frequency, both diffusion capacitance and transition capacitance cannot be ignored. These can be taken into account. After consider diffusion capacitance and transition capacitance into model. The model is called hybrid pi model. Now come to see the hybrid pi model. In this hybrid pi model can also be represented by using symbol also. Hybrid pi model can also be represented by using symbol also. In this symbol, this is the emitter junction, this is the emitter terminal, this is base terminal, this is collector terminal. I am taking one resistance between base and B and B is called dB and the input resistance is called RB. The resistance between B and emitter, that is called RB. And similarly, the capacitance between B and emitter is called CB. And one more capacitance between base and collector is called CB. And one more resistance we have between B and C is called RB. The output current is represented by output current, that is called collector current. It can be represented by IC is equal to Gm into dB, where Gm is called transconductance means transconductance can be defined as Gm is equal to output current by input voltage. Output current by input voltage. And also output resistance is there, that is R3. Collector to emitter resistance is called output resistance R3. So based on this knowledge, we are going to prepare hybrid pi model, finalized hybrid pi model to analyze the transistor at high frequency. At high frequency, we are going to analyze the transistor by using finalized hybrid pi model taken from this model. That is, it can be represented, it can be shown as RBB dash. It is the resistance between B and B dash, and the resistance between B dash and emitter is called input resistance, that is RB dash. Input resistance, that is RB dash, and input capacitance, that is the capacitance between B dash, the capacitance between base and emitter, that is CB dash, and also here output capacitance or feedback capacitance CB dash, that is CB dash, and feedback resistance. We have feedback resistance. It is the resistance connected between input and output, and the common element is connected between input and output is called feedback resistance. That is RB dash, and output current, that is it can be taken as Gm into dB dash, and output resistance is RC. This is the finalized hybrid pi model. It is used to analyze the transistor at high frequency. What is our final conclusion? In final conclusion, at low frequency